Hello everyone, welcome to Code with Femi. In this video, we're going to be looking at C# fundamentals for beginners. If you're actually interested in developing software, let's say you want to develop a desktop application like for Windows, or you want to develop a software application for Linux or for Mac, or you want to develop a web application or a mobile application, one of the thriving programming language that you can use is actually C#. I've been using C# for over 10 years now, and I would like to actually take you through the fundamentals on how you can actually use it to start developing amazing software. So we're gonna go through this actual information I have right in front of me, and the first thing I want to talk about is actually the .NET Core framework. What is actually .NET Core framework? So .NET Core framework is actually it's a development stack, or you can call it a platform that actually enables you to write your C# code, and that C# code is actually compiled into libraries like actual libraries that actually get stored on your hard disk on your actual machine, and then that actually gets compiled into machine code. It transforms your C# language into what the actual computer can understand, a language that your computer can understand. And if you see the diagram right in front of me, you can see that we have two different frameworks. So we have the .NET framework, which is the older versions, which is you have your .NET 4.6, you have WPF, Windows Forms, and these are actually specific to software that you want to develop on a Windows machine or a Windows operating system. But for .NET Core, it is actually cross-platform. It is actually enables you that you write your code and you can actually run that actual code, or you can deploy that actual code onto a Mac or a Linux, or even Windows, or even a mobile app if you want to. So in here you can see in the actual diagram right there, we have the common runtime, which is your CLR, your common language runtime, and that actually helps you to actually compile your actual code using the JIT, which is just-in-time compiler, to compile your code to what the actual machine can actually understand. And also you can also see that it's easy for you to actually come up with software in a much more nice way, and you can easily ship this thing out easily into any operating system you want to go into. And one of the actual links, like the vital links I've actually put here, is this one. This one is very vital. I'll put it also in my description below, but this actually teaches you the different architectures you can use with .NET Core. Your microservices, using it with Blazor, your containerization, all those different architectural design. You can actually get it from that link, but I'm also gonna do some videos on that at some point. But let's move to the next screen. The next screen is just what I want to show you, the flow of things. Let's say you are a developer, you're actually writing a C#. And by the way, you can see we have F# here, we have VB, which is Visual Basic. So you can write your software using any of these languages that we have here, but this is the one I'm going to focus on, because this is the one I'm going to be taking you guys through in this video. So the C# code actually compiles. So when you write your code, it compiles using the C# compiler into a common intermediate language, which we call IL in some cases, intermediate language, and that is your DLL. So your DLL stands for dynamic linked library, and that actually compiles your code into a file that gets stored on your machine, like I mentioned earlier. And then when you run that actual compiled DLL, the common language runtime actually uses JIT, which is a just-in-time compiler, to compile that actual code you've got into machine code, which is ones and zeros. So it makes it much more easier to write your code in a much more clear way, or much more, because if you're writing ones and zeros, it's gonna be difficult to really know what you've actually written, if you get what I mean. But it actually helps us to be able to, so the framework, the .NET Core framework, actually enables us to be able to write our C# code and compile it to what the actual computer understands. That's just the actual basic summary of that. And what I want to do is I want to take you guys the basic fundamentals, like I mentioned. So we've talked about the framework, which is the platform that enables you. And one of the two key components that actually a framework, the .NET Core framework, has is the class library and the common language runtime. Those are the two key components that is got. So the class libraries are actually predefined APIs that you can easily use to develop your software in a much more effective and in a much more fast way. So the next thing I would like to touch on is variable. What is actually a variable? Variable is actually a container that stores data. And also bear in mind that your variable, whatever data you're storing in this container, is actually being stored in a temporary memory storage on your computer, which is your RAM. So your RAM is where all this this actual data that you're storing goes into. And what I want to show you is what are the different types of the primitive. So primitive, when you hear of primitive types, this actually talks about the predefined types. These are the types that are already there based on the .NET framework, .NET Core framework. It's actually part of the actual inbuilt class library. Like I mentioned earlier, you just use them. The non-primitive types are the ones that you define yourself, and this, for example, a class is one that you're gonna define yourself, which I'm gonna show you. And enums, struct. So those types, those are the types, those are the non-primitive types. Those are the ones you came up with yourself. But the primitive types are the ones that are actually in there. You just use them. And also, as part of this variable, I'm going to also show you guys the ref and the out keywords that you can use with your variable. And what are the use cases, what do they mean. So let's just go to Visual Studio, and then in here I'm just going to create a new project. I'll call this project something straight to the point that would something just basic. So but before we do that, I'm just going to create a console application. And for you guys who are just new to this and you don't know what this is actually Visual Studio 2019. You can install it and you'll be able to also do exactly the same thing I'm doing now. So just create a console application. You can also pull a drop down here. You can select it from there. You just have to make sure that it's C#, and then it can be all platform, or you can say Windows, but all platform gives you all the different ones that is available as part of the pre-built templates. But this is actually a template. Then you just click on next, and then takes you to the next screen, and then here I can just say C# fundamentals. Okay, C# fundamentals, and then next, then we just create it. So this is gonna create just a basic console application, so that I can actually show you all these different fundamental basic components and things that you need to know in terms of C#, so we can actually start doing amazing stuff together. Just bear with me. I don't know, my computer is always happy. Yeah, it's back. So yeah, so basically you can see here that this is actually built for from scratch like it just gave us this application. And one of the things I want you to pay attention to is this actual solutions explorer. This is where you see all the different classes you've added, your project, your solution information. And then if you click on the drop down on dependencies and click on framework, this actually points to what I was telling you guys about .NET Core framework, which is there are actually class libraries within it already. And this is what you can see here that you can reuse. You don't really need to come up with your own stuff that is already here. You can always reuse most of the libraries they've got here. There's a lot here, which is it's amazing. It may help you accelerate things. You can develop programs even much faster, but it's actually part of the framework, the class library. And then as part of this as well, like I mentioned, is if I build this, so let's build this. What I did there was just Ctrl+Shift+B. That actually builds it for me on Windows. And then let's just go into where this is. So I'm just gonna say right click. I'm right clicking on that, and then I'm just gonna say open file in File Explorer, open folder in File Explorer. That should open up the actual folder where the project is. One of the things I want you to know is that in here there is actually it's gonna create all those compiled, you see what I mean? So there's a compiled DLL which I mentioned previously, and this is what gets, and the executable file as well. So this is what gets translated to machine code, and then it can actually the computer, the operating system can understand it and actually run it. So if I go back to this and actually just click on run, you will see there that this actual program will just run. And I'm just letting you know how this thing all flows through. So this is runtime. So you can see that the actual program is running, right, which is fine. And then you'll be wondering, okay, well, so what is variable? So we spoke about the primitive types. So the primitive types are the ones that are predefined already for us, and it's already there. It's actually part of the system itself. So if I go into this method, let's go into this method, and then let's just run one, which is int. I'm just calling this is one of the primitive types, which is int. I'm just gonna call this my first number, and then this I can pass whatever number I want to pass. And this is how you actually passing a value into this actual variable. Like I told you, it's actually a container to store your values. So this is a value I just passed in now, and with this my first, I can actually output it here, and then you see what is going to show up on the actual console. So let's save this, Ctrl+S, and then run it again. So like I mentioned earlier, this is going to be runtime. So when you build your application, that is compile time, and then runtime, you can see there, that is the actual stuff we passed in based on what you can see there, 1 2 3 4. This is just like a storage container to store your values. So just pay attention to that. That's what a variable is. Another primitive type that we have is double. So I can call this my money, and then we just pass in same story, and I think you can just also pass in D if you wanted to make this a double for you. And then if I run this, and also what I just want to do is I just want to make sure that you're seeing all the different variables that we've added. So I'll just say my first number, and then let's copy that line and paste it to the other line, and then we'll just call this my money. Okay, so if I run this, you will see that we should have 2 records coming in now into our actual, you see. So we've got my first number, my money. So basically these are just your some of the primitive types. There's a lot of primitive types, and then we have string as well. This is also a primitive type, which is a string. Let me call this my name. My name, let's just say code with Femi, and then we'll do exactly the same thing. Copy that line, my name, and then we'll pass in the actual data. So bear in mind, this is just a string, that I'm just putting in here, and then the plus is just to combine this value with the variable, the value we're passing in here. So if I run this as well, you will see that it's actually going to show me the the actual value that I've just passed into that variable. So like I mentioned, it is actually just the container. You can see that I've got those values I've passed in now, which is int, double, string. So those are your actual primitive types. These are predefined already, and you can see there's coming from the so let's just remove this. So let's go back to our code so you can see what I mean. So if you over on this, you can see they say system, that is the actual namespace is coming from, which is this actual system that you see here. And also I'm going to touch on this. So when you say using system, what you're doing is you're importing another namespace to use whatever component or whatever classes they've got in there, or whatever methods they've got in there within this actual space, which is this class that I have, which is my program class. So I can reuse. So it's all about reusing code. So there's a lot of things in there that I'm just reusing here. So this is actually coming from there. So you can see the system.integer, system. So basically these are the primitive types, and then the non-primitive type, I'll just touch on one just to save us time because there's still a lot to go through. But the other one is your class. Your class is your non-primitive type. So I'll just declare a class here just for this example. I'll call it my first class, and then in here I just want to do this. So I'll just copy that, and then I'll declare so my first class is equals to new my first class. So these are your primitive types, and these are your non-primitive types. This is the one I defined. So this one, I'm just going to put a comment here. This one are predefined variables, and then we have user defined variables. So in here you see I defined this myself. This is actually a class I created myself, and I'm using it now. I can just put a property in here so you can see what I mean. I'll make that integer, which is going to have a primitive type in there. I'm just going to leave it as my property. But this is how you actually instantiate, and this is actually a class. This is how you instantiate a class, a class, and this will create a new object. This is actually an object now, and then within this object I can now set my property here to whatever value I want to set it to. I'll just set it to something else. Let's just call this 578. Then we'll terminate. Another thing I want you to pay attention to is you can see there's always a semicolon every time I do this. This is how you terminate a line of code. This is very crucial, because if you don't have that, then your code would not compile. If I remove this, for instance, you will see there's going to be red there, and this is to tell me that there is not I don't have that semicolon in there. That is what you need to pay attention to as well. You have to make sure that you have a semicolon every time you write a line of instruction or a line of programming code. Just make sure that you terminate it like that when you're done. That is how you come up with, when you set a variable, terminate it. When you instantiate a class, just make sure you terminate it. So that's how we do things in C#. And then you just have to make sure that, so for my property, which is coming from this actual class, is what I'm just setting the value to in there. But also one thing I want you to pay attention to is this public. This public is saying that this actual property can be accessible outside of this class. If I don't want that to happen, I can make it private, and that would give me a red flag here to tell me it doesn't know what this. You can see, if you check what is written there, it says my first class dot my property is inaccessible due to its protection level. So I'm going to deal with encapsulation later, but for now let's just focus on this. So basically you have that, which is my property, and then you have let's set this back to public, which means that I want it to be accessible by another class. there you have that, and then I'm setting that actual value to it. And then what I want to do is I just want to copy this, and then I'm just going to copy my first class property there, and then paste this one there as well. And then let's just run it. Just gonna zoom out a little bit. Let's collapse this a little bit. It's just too much of in our face. And then let's run it, and then you will see that this is actually going to print out all the all the values from those variables. So that's actually how you declare your primitive and your non-primitive types. You can see there that I now have this one, which is the one we just passed in, which is your just trying to see if you can see, okay, which is your 5678, which is your 5678 there. So that is actually how you do your primitive types. So let's just go quickly to the other one, which is your ref and out. How you use that with your variable. So let's say, for instance, you have a method, right? You have a method. Let's just create a new method within this class. I'm just gonna zoom this out a little bit so we can have more visuals. I'll remove that. I think we happy with all of this. I'm just gonna clean this out for now so I can have more space to do stuff. Okay, so let's say that we want to deal with a variable that has the keyword ref. So the first thing you want to do is you want to have a variable. That's the first thing you want to have. So let's just call this my first ref variable, and then let's initialize this actually. So I'm doing the ref one, the variable with the ref keyword, right? So let's just say 234. And then the next thing you want to do is just want to create a simple, let's just create a simple static method. Let's make it void, which means that it doesn't have any return type. I'll go deeper into the method when we get to that stage. There's actually a session for that. Method, right? This is a method. I'm just going to call it method for now. And then in here, the argument you're passing into this method. So this method is actually like, you can pass in arguments within that parenthesis, within this this actual bracket open and bracket close. So in there you just want to say the keyword ref first, and then int, because I want to take this thing in. It has to have the same data type as the variable I'm trying to deal with. And then I'm just gonna give it a generic name. Let's just say value. So what it's gonna happen is, if I call this method here, so this is a method, I can call that method now with that variable, but now I have to just say ref. I just have to give it that keyword to say it's a ref, and then my first variable, and there I just gonna say console dot write, and then we'll just log out the actual value of that my ref variable, right? Let's just log it out. Let's run this quickly and see what happens. So you will see that when we run this, what do we see? We only get the same value we actually passed into that method, right? 234 was what we passed in, 234 is what we got out. So now let me now show you what the ref does actually. So remember that this actually, the actual code runs from top to bottom. So, and I'm gonna put a debugger here so you can see what I mean, just to stop that code at that point so we can debug through. Here you can see that so in this method I just want to now change that value to something else. I'm just gonna say value is equals to 123, and then I'll run this. When I run this now, what is it's going to happen is that it's going to stop at that breakpoint that I just added now, and then we can just actually step through it together. So F10, you go down like that. Let's go, yeah, F10 down like that. You see the value there, you can see it's 234, right? See, you can also check it on your autos. You can also even put it on your watch, right? Copy and paste it on your watch to see what it is. It still gives you 234, right? Good, that's the value it has. But now it's gonna go into this method. And how do you get into this method? You can use F11, or you can use the step into. So you can use the one on top here, which is still F11. So it's going to step into this method. You can see it actually leaves that place here. It doesn't call that line. It's actually stepping into this method now because it's a new method. But if you check the value here, is 234, right? And then if you press enter to step, to step over, and then we, F10 again to step out of that method. If you go to the next line, which is console, so we have not console it out now, but you can see the value changed. So it changed from 234 now to 123. Can you see that? So ref is actually a way of actually like manipulating the actual data. You can see right there that it's now 234. You can see right there. It's now 123. You can see 123 from 234 because I changed it here to 123. It's going to change. So this is how you actually make use of a ref keyword, where you pass it into a method and you want to like change the actual value of that variable. So that gives you like that flexibility to manipulate this in another method if you want to. And so the other one I want to quickly touch on is the out variable. So the out variable, you don't have to assign it to any value, but you have to make sure that so the difference is you have to just make sure that the actual variable, so I have to just change this method now to out, because it's no longer, I'm doing the out one now from the ref. So you can see the red is gone now, which means that this is an out keyword variable. I pass it into that same method, and then in here I just have to make sure that I set a value to it, because remember at this top here I'm just declaring it, but it doesn't have any value. And if I take out this, you will see that this is going to become red. You can see there. And what is it saying? It's saying the out parameter value must be assigned to before control leaves the current method. So that means that it has to be set. So that means that I have to set it back. So value, I'm just going to change this to 978, something like that. And then don't forget to terminate as the normal practice. And then when you run this now, you will see what is going to happen in terms of the out variable. So the out variable is, you don't need to assign any value to it in the actual in the place where it's declared, but you have to make sure that whatever method is using it must set a value to it, or else it won't even compile. And if I move it now to let's move out of there, and then you will see on the console itself that it would have changed now to that value which we have in here, which is 978. So you can see there that this is actually just basically we've touched on the variable. I hope you guys are learning, and I hope you guys can also test this all different examples I've shown out yourself. Just play around with these different variables. There's a lot of variables you can play with, different primitive types. You can come up with a non-primitive type as well by yourself, but this is actually variable we've covered on. So let's move on to the next one, which is let me just switch back to our presentation. Let's move on to, so let's do namespace. So what is actually a namespace? So namespace is actually a container that actually like groups all your related classes together. So if you have so let's go back to the IDE. So here you can see there's already a namespace declared, and this namespace C# fundamental has a class program, and also I can create my own class now. Let me just create my own new fresh class, and also I'm just gonna touch on class as well, as we already there now, because class namespace, all that is gonna be touched on here. So let's say my first class, right? So my first class, I'm just creating my first class, and in there you will see that my first class already has a C# fundamentals. All this you can see is actually namespaces coming from the inbuilt libraries that we've got on in .NET Core. So I'm just going to take this out for now. I don't want to focus on that because this is the major one. But yeah, you can see that is actually C# fundamentals, and I can actually change this. I'm just going to like show you what I mean by like grouping classes in namespaces, because namespaces are containers for classes. If I remove this, I'm just going to call this one, my namespace now for this one is C# fundamental without the S. I'm going to make this public because I still want it to be used by another class. And let's just make it static as well. Static, so there are different types of classes you can have. So static class cannot be, you don't instantiate them, and they're basically you just have to you call the methods in them without instantiation. You don't need to initialize them. In terms of your non-static one, you need to instantiate them, and that is actually so the difference between a static and the non-static is that the non-static one is by reference. It creates objects for you. The static one is always just going to be static, like it's like the word implies, is static. You're only just gonna get one at it. You're not gonna get different different objects anytime you instantiate it. So with that being said, if I make this static, I'm just gonna come in here. So you can see it has a namespace, it has a first class, and in there, in my program class, if I want to use this up here now, for instance, and say my first class, you will see that it's actually red. You'll be wondering, why is it red? The reason why it's red is because it doesn't belong to this namespace. Remember, this namespace is a different namespace entirely. This is actually a different namespace entirely. This is actually with the S, fundamentals, but the one I have is without S. It's fundamental. And how do I get this class to be used here? How you do that is through the using. You import that namespace. You can use the actual helper, the IntelliSense that helps you to suggest, what you can do. You can see it shows me that namespace that I spoke about, which is C# fundamental. Let me just, humor me a bit. I'm just gonna change this to code, with Femi. Let's just call it code with Femi, and you see what I mean. If I go in here again and try to resolve this, you will see what is gonna show me now. Code with Femi. So whatever namespace you give it will show up, and then this is how it's going to import it, and that is how I can use my first class now. You can see there that my first class is showing up, and this is how. And remember, this is actually a static class, so I can't instantiate it. I can just use it. What that means is I can get a variable and just say my first class, let's say property, and I'm just gonna add a variable in here that I want to set. So I'll just make it a property in here, int my property, and then in here I can actually just say my first class dot let's just go to okay, this is not stat. Let's make this static as well, and then you can see that my property will show up here, which is basically like how we do things here. And what I can also do is I can even say that this is actually just going to have its own value from here, which would be a field, and then in here I can easily grab that actual my class property and pass that into like a so this is a variable. So let's take this out so we don't confuse ourselves. Remember, we just want to pay attention to what we're focusing on, because we just focusing on namespace and how that relates to a class. You can see there that I have my first class, which is static class, and then I have my property, and then my first property class goes into the console line. If I actually, and that value is already been set here to 1 2 3, or I can make it 1 1 1, whatever it is I want to make it. And when I run this, remember, it's always going to save the files that are unsaved, and then it's just going to build it. You can see it's building. It's going to build the project for me, and then it's going to just run it. Let's just see what's going on. Okay, there's a breakpoint here that I've just put. I'm just going to take away the breakpoint. I don't need the breakpoint now. I just want to you can see there that there is 1 1 1 that we've just set in the actual class. So that's actually your namespace, and that is actually your class. One of the things I also want to touch on is actually, the types of class you can have. We've spoken about static, we've spoken about, so non-static is you just take this out, and that makes it non-static, and that means that for this class to, so let's do this, and let's just make this like this. So for this class to actually work now, we just have to make sure that we instantiate it here. So for a non-static class, you have to instantiate it. It has to be instantiated like this. So you're saying my new first class, So that's what you do in here. You say my new first class, and then you can just now in the next line, because this is now an object, and then you can say dot my property, which is equals to, you know, whatever value you want to set it to, and then that can actually be fed into the, you know, console write line application, and that would actually like give you the value that you're expecting. So when this runs, you can see basically it's the same value we have here. That same value we have here is what we have there. So that's actually how you declare your actual, you know, static and non-static class. If it's a non-static class, you have to instantiate it. If it's a static class, you don't have to instantiate it. You don't need to instantiate it. But one of the things I want you to pay attention to is something vital in a class. A class has a constructor, and the constructor is actually what you use to instantiate you know, some of the variables or some of the dependencies it has that it needs to actually do what it needs to do. We're actually going to touch on that later when we start dealing with dependency injection, you know, dependency inversion, doing unit test and all that. But for now, I just want to focus more on, you know, the constructor. The constructor is actually the entry point to this class. So, and the constructor actually can have arguments. You can pass in argument into the constructor into this class. So let's say, for instance, I want to pass in an argument. I'll just declare it by giving it the data type first, int, and then I can give whatever name I want to give it. For this one, I can just say my first argument. Okay, my first arg, let's just call it that. And then I don't want to set this here, and also I want to make this let's just make this private. Let's make this private, and then let's make it read only. So read only means that this can only be instantiated, and then we'll change that to you know, camel case. Another thing I also want to mention whilst I'm at this is that you can see the naming convention I'm following. That I'm following a Pascal case, I'm following camel case for some cases. So your classes would have Pascal casing. What is Pascal casing? Which means that each word, the first letter of each word must be uppercase. That is Pascal case. Each word, you can see mine is a word, first is a word, class is a word. So you just have to make sure that the first letter of each is a capital letter, and that is for class. For method, the same story. For public properties, we use Pascal case, but for camel and also for namespace as well, we use Pascal case. But for things like private, we actually use underscore in front first, and then this tells you that okay, this is actually a private field or private property, and then we make sure it's camel case, which is your M. You can see here your first letter is a small letter of the word. Small, the first letter of the first word is a small letter or a lowercase, and then the next word will start with a capital letter. That is what the camel case is. And then we just make sure that that is set within here. You can see also the argument you pass into your methods are actually camel case. Just remember those naming conventions. That's how we do things in the, you know, in the .NET space. And also there's also another file you can even install on your solution. It's called, I think, editor config that also helps you to conform to some of this naming conventional standards as well. But the major focus is to pass in that. So this is the argument. If we've passed in that argument, and what I can do is I can just say I can create a method here. You can say I've been touching on method, so it will be much more easier when we get to the method point. But this is actually a void method. Void means that this method does not return any value. It just computes and do things. Okay, we can just say write out property. Let's just say property value. All right, and then in here, all we just want to do is we want to just console.write out this guy. So we just say console.write line underscore my property. You can see there's a private field there. It's clear. You can be wondering what's happening here. This guy is not red. It's because the names, there's no import. I'm not importing any namespace. Remember, console is also part of the pre-built you know, library stuff you can use. Some of the classes they have there. This is a console class. You can even see, we can actually see if we can, you know, go into the actual class itself. You can see it's actually in here, and it has a lot of function in there as well. But these are all inbuilt. I didn't write this. Can't you see it's amazing? So it's a lot of things they've already like done for us that makes it much more easier to actually develop your software even much faster. But what I want to focus more is actually, you can see there that you have console, and then we're just writing that out. So now the question you're going to ask me is, how do I use this class? How do I use it now? Basically, all you need to do is we just have to instantiate it like we did here. But you can see it's already red here. It's like it doesn't understand what's going on. Number one, this my property is gone from this class. Remember, we renamed it to underscore my property. So this is gone. So that means we can't do this anymore. And also you will see that so what we'll take this out, and then we can just say write, we can call this method directly from here. But the first thing I want you to pay attention to is this actual thing. You can see there that this actual class now needs you to pass in an argument, which is expecting my first argument. Let me just duck a little bit. You can see there that my first arg, that's what it's looking for, right? So what you want to do is you just want to pass in the type it's looking for, which is an integer, which is a number. So we just put in we could put a number there, and everything is golden. You see that everything's happy now. And if you go back to your class, let's see if I can do some some amazing stuff here, so you can see, let's split our screen. That's another benefit of you working with IDE. You can easily do something amazing. You can do it this way, or I know some people like to do it side by side. We can also do that as well. We can put it on the side here, and then you have this one here. But I do actually prefer the one below. That actually, it's nice for me just to compare things. But if you check here, this is actually your first class, which is what you've declared here, and then you have your private property, which is not accessible by any external class. It's only accessible within this space. Because if I try to do something like this here, it will tell me no, I can't do it because it's not accessible. But let's just try, just for me to show you what I mean. If I do so my first class, and then let's just do this. Let's just pass it to another variable, and let's just say my property. Okay, and in here you can see it's gonna be red, and it's telling me I can't access it due to the protection level. So just pay attention to that. But you can see there that this is my constructor, which is the entry point to my class, and that's where we pass in that variable, that actual value into this arg. It will set it to that private property, and then on the next line we call in write out property value, which will just console log this actual thing out onto the terminal. So let's run this and let's see what happens. You can see there that the actual value is actually being logged, which is what we've passed in, and that is what is actually being initialized by the actual that is being written out onto the console. Yeah, so whatever value you pass in here, so that's how you pass in. Now you can have as many args as you want, but it's good to just keep it as as basic as possible. So I can have another argument and say my second my second arg. Okay, my second arg, like that. You can see that is red already because I've added a new argument onto this constructor, and all I just have to do is I can just say code with Femi. I can do this, and then in here I just have to also like find get a new variable, a new field, and then I can just say my second property, and then in there I just have to do same story. I just have to pass in the value I'm getting from this actual second argument into my constructor, and then my constructor I'll just log it out here as well. So always remember the left part is always the receiving part, the receiving variable. The one on this side is the one passing the value. So always just remember that. And then if we run this, we'll see that it's gonna log this number, and as well as gonna log my name. So that is actually the basic, the basic stuff around, your class, and as well as, your namespace, what makes up your namespace and all that stuff. So that's actually just, the basic stuff that I want to show you guys in terms of that. And if you're still here and you're still watching, congratulations, because at least you now know what a variable is, you know what a namespace is, you know what a class is. So you're getting there, you're learning a lot as you go along, which is amazing. So what I would just encourage you is to just keep on watching, because all this is actually vital for you if you want to become a C# expert. You just have to make sure that let's see so it's actually here. You can see that I have it, code refer me like that, so it's actually there. But as I was mentioning, we just have to make sure that you keep on going. This is one of the things that you have to also try to understand. For you to become a successful person in an IT space, you have to spend time studying, researching, watching a lot of videos, learning all these vital things, and then you'll be solid before you know it. But this is actually it for for the class. We've touched on class, basic class, your constructor. Now you know what the constructor is. And then now you know what the namespace is. It's actually a container for your classes, your related classes, to group your classes together. In a way, you know what the method is in a way, but I will go deeper. So the next one I want to focus on now is some of the other types that you have. So one of it is the abstract. What is an abstract? What is interface? Those things are actually one of the things they even ask you in interviews, and you'll be like, what is the difference between an interface and abstract? But yeah, I'm gonna show you all that now. So in this actual code, let's just go back to the code base. What is actually abstract? Abstract means that it is actually a class. It's a class type, but what you're saying is this actual abstract has to be inherited by another class. And what I'll do is I want to just change this name from my first class to parent class. So picture this as like your parent, and this has to be inherited by a child class. So I'll just call this child class. So this is where we touch on things like inheritance. Like your father has a land and you want to inherit it, or your mom has a yacht and you want to inherit it. This is what happens in terms of inheritance. So I'm just going to touch a little bit on inheritance, and then we can actually just move on quickly. But basically, abstract classes are always needed to be inherited. And one thing about abstract classes, you can't instantiate it. You cannot instantiate it, but an abstract class can actually have a constructor. So it also has its own constructor, which is also going to be the same thing, which is basically the name of your class must match the name of your constructor. That is what makes it a constructor. If it doesn't match letter for letter, then it's not a constructor. It has to match. And then one of the things you can see here is that I've actually added a constructor, but I don't want to make it too complicated, so let's just remove that for now. But what I want to do is I want to declare an abstract method. So how do you do that? You just say abstract, and then let's make this void and just say my first abstract method, like that. So your first abstract method, you've actually added one, yeah, right? You can see this actually became red immediately. Why did it become red? Because every class, every child class that inherits this actual parent class must implement this. That's what it's saying. And I'm just going to click on this, and then you see what I mean. So it will just implement that. And that actually takes me to I think I would actually even touch on method already, yeah, because here you can see override. Override is actually just going to override that. Another thing you can also do is you can actually have another one which is of type virtual, and I also like give you the difference between the two, which is my first virtual method. Okay, a first virtual method. You can see here that this doesn't have a body. So your abstract method, they don't have bodies, but the virtual one actually has a body where you can do stuff. So yeah, I can say console dot right line, and then I can say sorry, it has to be double quotes, and then say my base virtual method. Okay, and then in here, so you can see I've implemented this. This is not implemented yet, but I'll just, let's just copy this guy and let's just like override that, and then we'll call this my child abstract method. So basically what we've done now is we've just actually created two amazing classes. So this is actually the abstract one, and the child one inherits that one. Okay, and then just bear in mind any abstract method in there must be you must override it in the derived class. We call it derived class. So this is a derived class, even though I call it child class, but it's a derived class, and this is the super class. Okay, and sometimes some guy call it base class. The parent class is called a base class, sometimes it's called super class, whatever floats their boat. But what really matters is that this is actually the base, the main class, and then you have a child that actually extend on it by you having a colon and then the class, like that. And then if I go into my so let's say I actually go into my my program, let's remove that, and then let's just say let's actually use our parent class, right? And let's say my parent class is equals to parent class is equals to new child class, right? So this will actually like instantiate the child class as the parent. Okay, and the reason why this is possible is because there's a relationship between a master class and a child class, right? And then your parent class can now be used. So yeah, the method we've done here is two. We've done my first abstract class. Let's try that first, and then if we run this, let's see what happens. So that's the first thing. We're just testing out the abstract class and see what happens, right? You can see there my child abstract method, it's actually calling this method within here, even though we're using this class, right? And also if I do this, so let's do the next one, which is like saying my first virtual method. What do you think this is going to log, the second one? Just think, I will just guess before it actually opens up on the terminal. If you can guess, and yeah, that would be great. That means you're learning. But basically you can see there is actually using my base virtual method, right? The reason why it's doing that is because this actual virtual method is not overridden yet. These two actual method you see here, abstract method and virtual method, are actually methods that can be overridden, or you can override in the child class or the derived class. So if I want to override this, you're not forced to override this if you don't want to, but if I want to override this, then I just have to come in here and actually set up the similar one in here, right? But just bear with me. I'm just going to change that now from virtual to override. So this means that I want to override what is actually set here in the base class. So yeah, I'm just going to change this to child virtual method. And if you go back to our console, just bear in mind, see, before initially it was my child abstract class, abstract method, and my base virtual method. But now when I run this, what do you think is going to happen? It is going to change that virtual now to the child. And this is how you do overriding. This is how you override. You can see there, my child abstract method, my child virtual method. So this is how you do overriding. So I can actually go ahead and actually create a new child to say this parent has, say, a second child, right? Second child. And then I can just, let's just grab that. I'm a little bit lazy. I'm just gonna, grab that. My second child, right? You can see it still inherits from the actual parent class. So in the program, I'm just gonna change that now to second child. And what do you think is going to happen? It is going to override what is in the base class and actually print out my second child. So that's just actually it. This is just for abstract. Basically, abstract can also have constructors, like I mentioned, which is basically you can actually pass in information in here. So let's say I have a method here, a constructor here, and let's pass in an integer this time and just say value, right? So when you have this means that whoever is inheriting this must also must have a constructor and actually pass down the actual arguments to that actually base class. And how do you do that? You have to declare the constructor first for your derived class, and then put in a colon and just say base, and then open up the parentheses, and then in there, remember this is actually an integer, so we can pass in a number in here, which is whatever number we want to pass in. And that is it for for that. And we can actually do exactly the same thing for this one. So any child that does use that base, that parent class, must actually just make sure that they pass in a value into the base class, and this is just me doing things quickly. But you can actually say int and then value, and then in here you can just say value. If you want to pass it down from from whoever is going to consume this actual classes, you can actually just do it this way. So that means that value can now be set within the constructor here. You can see this is red now. I can now set this in here. And also what I can do is I can console log this in here to say value value passed from child class, and then we just say plus and then say value, and this will just show us what value they pass it down. Okay, let's run that. Let's see. Okay, we're using a second class, are we? Yeah, it's still gonna print it out actually, because we're already passing it in there. So you can see there that we have value passed from child class, which is this child class, this one. It will just pass it on to the base, which is, so if you can F12 on this base, you to take it to the parent class. So now you know how abstract works in a way. Abstract can have constructors. Abstract can actually have abstract method that doesn't really have a body like this, where you do all the logic that can be that you can override in a child class. And virtual, they can also have virtual methods that can actually be, you can override in the actual child method as well. So that is actually you've learned core things here. Now you've learned abstract. What abstract is, it's actually a class that should be inherited, that needs to be inherited by a derived class. And then in a case where you have something like this, that means that it doesn't necessarily have to be inherited, and it doesn't need to have that abstract. The only time you have an abstract method is if it's an abstract class. Also pay attention to that, and you should be fine. So that's actually it for abstract. You have to just take this out from your child classes, because this is actually, I've changed that now to something else, which is doesn't have a it's not an abstract, it's just an actual class. There are cases where you want to have just an actual class and you just want to inherit it by your child classes. So you can choose whatever option really works for you, but you can still have a virtual method in there and you can override the virtual method. So whatever actually you want to use is still fine. It doesn't really matter. It just, all that matters is you just have to make sure you structure your code in the right way. So that is actually it for abstract. Let's move on to the final one, which is the interface. I'm just going to change this now to interface. So I'm going to clean up all this. I think we're done with this abstract example. Let's just move on to interface. What is actually an interface? So interface is actually is a way to actually like expose the contracts on your class. So if you have a class and you have implementation in the class, and I'm going to show you what that means. I'm just going to call this child. So another convention we follow for interfaces, we make sure that I is the first keyword, the first letter we use as the name, and then followed by the actual name of that actual interface, for which it follows the the name of that class that is going to use it. Or if it's going to be a generic interface, then you do exactly this. You can actually give it a very meaningful name. Also pay attention to the name you give to your classes, your interface, your method. All that really matters. You can't just call your method something that it doesn't do. So just make sure that you bear that in mind. But basically in here, one of the major things you have to know is that this actually just exposes all the public methods you have and public properties you have within this class. And what does that mean? I'll show you. So let's say I created a public void method. Let's say we call this void. Let's just call it void method, right? This is a void method, right? Now this void method is actually in here, right? And then let's create another one and call it int method. I'm just giving it just my own random name now. We call it int method, right? And in this one we'll have to return an integer, right? Which is, let's just say it's returning 1 2 3 4, and then let's say it has a string method, which is string method, right? Then you have string here. So your string value must have a double quote. Always pay attention to that. It has to be a double quote, not a single quote. So string is double quote, the value double quote. Or let's just call this code with me, right? So that's my string code, which contains white spaces and the whatever thing you want to put here. You can put anything you want to put. It doesn't really matter. You can do whatever you like. So just bear that in mind. String takes anything. It's like anything, any value. So we have void, which doesn't return anything. We have integer method, we have string method, right? Now you might be wondering, so one of the things I also want to do is I just want to like log, like print out what is in here, right? I think that would be the ideal thing to do. I'm just gonna write what we have here, and then we're just gonna write what we have here. And also, like, one of the things I also want to do is let's just pass into a variable. Let's just call it string value. Okay, that will be fine, just to reuse the code as well, because always pay attention, always make sure that you reuse your code so you don't always duplicate everything everywhere. Also same story here. I can just say var int value is equals to 1 2 1 3 4, and then we'll just pass that in instead. Okay, now you're getting the hang of it, right? Now you know how to set up a variable. You can use var, which the value you pass in determines what it is. Yeah, you can see it actually changes it automatically for you to integer, because based on the value you pass in it. You can also want to explicitly set it to int and then set this to string. Yeah, whatever option you want to go with is fine. But the major thing is just make sure that your actual variable names, your method names are actually like explicit as to what they're doing. Yeah, I'm just gonna say void method. Okay, let's just console write that. But now you can see that I'm inheriting this, but I've not exposed anything here, right? Because this, like I said, this actual interface is just to expose all these methods, all the public methods and all the public fields that you have in a class. Sorry, I think that naming convention is wrong there. So always pay attention to your naming convention as well. The methods are Pascal casing. But now you can see that I've not exposed anything in here. Okay. Now what you want to do is you want to just try, let's just try this thing out. Let's so it's red again. I'm just gonna like drag this and put it in between here so we can see what is going on. Right, let's just say child. So how you instantiate is you say I child. Okay, I child is let's say child class, and then in there we just pass this on to child. Remember, the constructor we're using is parameterless, so you don't need to pass in any argument. So let's remove this ones that we've added here, and then in here you can see that we have child class is equals to new child class, right? But guess what, if I do child class dot, there's nothing in there. Why? Because I have not exposed anything on this. And if I remove, for instance, this, there is no relationship. It's gonna tell me what is going on. I don't know, you know, I child class doesn't have any relationship with this. You can see there. So you just have to bear that in mind, that the relationship really matters. I child class inherit, so child class actually, you know, exposes is implementation using the interface, and interfaces don't have constructors, so you can have like constructor in here. That's another thing you have to bear in mind. So if they ask you what's the difference between abstract class and an interface class don't have constructors, they don't have abstract methods, they only have public contracts that you want to expose. So just bear that in mind. That is the actual difference. So when you go for your interviews, always just remember that. But the actual idea is that you see here, you can see all the different methods that we have here. But how do I expose it? The way you expose it is you just have to like expose it using this actual part of the signature, which is the actual return type, which is void, and then the method name, and then you just terminate it. I hope you saw that. This. So I've exposed just one for now. If I now go here and say child class dot void, and you see there that I can actually call that now because I've added it here, isn't it? You can see now I can expose. So if we run this, what do you think is going to happen? It's going to console log this information out for me. Okay, you're gonna see now what it's gonna do. You can see void method is gonna console log out that method. So, and if I put a breakpoint here, you can see that even though we're using, you know, iChild class to instantiate the new class, it's gonna still step into this class because they have a relationship. You know, this class is the concrete class, so we call this class the concrete class, but the interface is actually just, you know, the class that exposes the actual implementation to anywhere it needs to be used. And I'm gonna go deeper into this when we do, like, you know, your dependency injection. Like, it's something that we're gonna touch on. But you can see here that the breakpoint is it. You see there, is it? And it actually just logs the information out. So that's the actual stuff about interface. Interface is what I use most of the time, and you know, it's really good to make your code clean. You know, it makes your code, you know, you can reuse, you know, your interfaces everywhere in your code without having to worry. But that's actually one of the key things that I want to touch on. So I think we've actually touched on a lot. The other one I want to quickly, you know, focus on is, I think I've touched on methods. I don't really want to go to methods anymore. I've done methods already. We've done, you know, some of the variables, done namespace, we've done class. The one that I want to quickly focus on now is let's go to it, control flow. So control flow is actually what I want to focus on now, which is your if else switch for each using while try catch. Because that is actually, you know, one of the you know, the key things in terms of, you know, development. You know, you need to know all this different flow. So yeah, we've got basic things that you have to just bear in mind, which is if else. So these are actually like things that actually deals with conditional. So, and I'm going to show you that right in the code. Let's just go back to Visual Studio to Visual Studio IDE. I'm gonna focus more on just using my program class now. Let's go back to the program class, because everything that we're doing can be done here. So if is actually like, when you want to deal with conditional statements. So when you open up a bracket like that, you have to pass in a Boolean condition. One of the primitive types I didn't mention is this one, which is visible is equals to false. And then that is actually one of the primitive type that you have, which is either true or false, right? You passing that into that. Once you have if, so what you're saying is if visible is false, then that means it's not going to step in here, right? What if I say if visible is true? So anytime is actually true, your statement is going to step into this block and do whatever you ask it to do. So there are cases where you have, for instance, let's say you have integer count is equals to 10. Let's just say 10, and let's say this is actually coming from an external endpoint, and then you want to check, okay, you can do something like this. If count is greater than 10, that means you want to go in here and do something, right? And you can actually add additional like conditions. It doesn't stop you. You can build up different conditions, and that takes me to operators. Then you can just say, so there are different types of operators. We have, and these are the ones I used and. This is to say if this condition and this condition is met, then do this, right? So you have and, you have or, which is if either of this condition is met, then go in there and do whatever you need to do. Like those are the key ones I use, which is your and, your or. And you can have cases where you can say if it's greater or equals to, or you can say if it's less or equals to. So those are the operators I actually use for, in most cases, for my if statement, when I have if statement. Another one that you have to bear in mind is that if you have an if statement, you can also have an else if. So that means that if it's not that, then you want to say if is less than, if count is less than 5, then do something else, if you get what I mean. Like you can build up, you can continue going. This thing can keep on going as you want it to go, like there's no stop to it, but it's just that it becomes unmaintainable. You can't maintain this thing, can keep on growing. And this is where you can now say, okay, if else that, if else this, then else do this, right? But if you see that your if else, if and else if, it's happening many times, I would suggest you actually make use of switch. But before we go into switch, let's just see how this thing flows, like how the control flows. Basically, let's just say money, right? I think money is always something that people are always happy about. So let's say if money, if money is greater than, let's say if money is greater than 5,000, then console log dot write line and say party time. Okay. Or else if money, so let's remove count because count is not declared. Count is less than 5,000, then we can just say try to survive, and then we can just say else. So with else you don't have to pass in a condition. It doesn't, else is like a default. So if else, then you can just console something and say help me, or something like that. So something like this. So this is a control flow, which is you now trying to decide, what section of your code you want to run or execute based on the condition that is being passed in. and this is how you actually follow the flow. If I run this, for instance, what do you think is what block do you think is gonna step into? Just guess before it actually loads up. It's gonna hit that breakpoint though, but it's gonna step it into this one. The reason why it's gonna step into this one, because money is greater than 5,000, because we set it as 10,000 and it's visible is true. But remember, this is all. So if either of this, if this is true or this is true, is just gonna step into this block. You can see that that's the control flow, and it will just console just that one, and then it will just exit the actual if statement. You can see party time, right? So let's just let's close this. I think my computer is getting really tired now. Okay, and then let's go into the next flow, which is, let's say this is actually saying and, right? And let's say this is actually like false. This is actually false. This is not true. So that means these two conditions must be true for it to step in here, but these two conditions are not true now because I've set this to false already. And this money now, I'm gonna reduce it to 2,000 rands. Okay, or let's just put another and here. Actually, I want to say if money is greater than 2,000. Okay, so let's say or equals to 2,000. So let's choose that this is actually the condition to step into this block. Let's run this. So remember, we've set this money to 2,000, right? So what we're doing now is we're actually saying that if this money, so we've got money of 2,000, and what we're saying now is visible is false, which means that it's not really visible. You can see it's going to step over that block because that condition is not met, because we're saying money is greater than, and money is not greater than 5,000. That's why it's saying false. You can see there, and is visible is also false. So that means this is not true. It's going to try to run the next block of of the statement, which is this one, but it's actually true for this one because money is less than 5,000, because money is 2,000 we've set here, and money is equals to 2,000. Is either equal or is equals to, you see that. And we can also even change that to so let's just run this first and you can see what that will give us. So this will give us try to survive, right? Try to survive. And then if I actually just change this to equals, means you can actually make it double equals to actually specify that it's equal. If you don't want to do greater or equal to, you can just say equal to. And also remember, your condition is not only based on only bool cases. You can actually do like a boolean. This is a boolean expression. This is an actually expression for boolean. Also you can actually say string and say access. Let's just say access is code with Femi, right? I just want to add an extra stuff, and then I actually come in here to say and access is not equal to code with Femi. I just want to, so I'm trying to force it to not go into this block. I want it to go to the last block, right? So if I run this, what is going to happen is it's going to compute the first one. Remember, it's going to run from top to bottom. It's always top to bottom, so always remember that, top to bottom. And then it's going to skip that because that is not actually valid. The next one is also not valid because access is actually code with Femi, but we're saying it's not code with Femi. So it's gonna come in here to say help me. So yeah, that's your if else. We've covered if else, if, and else. So now you know what that means in terms of your control flow. So this means you can just control what section of code you want to run, and then you're happy. So that's your control flow. That's one. So like I mentioned earlier, there are cases where you don't want it to do, like, actually you don't want to use if else because it's just too messy. and it's just going long. So what we do is we use switch to handle that. Switch actually help us handle that. So I'll just pass in money. So this is how you declare a switch. You just actually say switch, and then you pass in the money, and then in there you have case scenarios that you're dealing with. So yeah, I can say in the case of where money is 2000, then you can console log on right line, let's just say survive. Okay, and then you just have to remember to break the case. So that's how you actually declare a case. Basically, you actually just say switch, you put in the actual condition, which is your, the value you want to like check what case it is, and it only deals with one single condition at a time. You can add more. Now I can say, it doesn't take more. This forces you to actually just use a single key to do the flow of things. But yeah, you say money, and then I can actually like add more cases. You can add as many cases as you want, and also within your case. So in here, just remember that your case must be unique it must be unique in the switch. So this one, I can say this one is 5,000. You can just say get in there, and then the next switch can be 10,000, and you can just say party time. All right, party time. And then if I run this, so I'm just going to clean this off. And also you can still have like if this, and you can still do your if within your case. So it doesn't stop you from not doing that. You can do if that, then console this, or else do something else. You can also do that. And also in terms of your if statement, you don't really need the coily brackets. If it's just one line of statement that you're dealing with, you don't really need those coily these coily brackets that I was adding, the coily brackets. You can just add it like this. So it's whatever you want to do. You can still do your if within your switch if you want to, and that's how you do it. But I'm just going to take out these conditions because I just want to focus on that money, because that is so when I run this, guess what is going to happen? It's going to actually step into the case where it matches in a way. That's just actually it, you get. And if you check now, let's just run this because I put a breakpoint there. Let's continue. You can see there survive. So survive is actually what we mentioned here. Survive, you can see there, survive. And then the next one is, if I change this now to, let's say 5,000, and then I run it, then this would actually just do the next case. So that is actually how case actually really works. It's basically going to just trigger the case that you have in place. You can see it's now getting there, which is the next one, and then I can just say 10,000, which will just actually just print out this one we have here. And another thing I want to mention is that you can also have a default. So you can have a default, which means that in your switch you can actually say that, like, if all the cases are not being met. So you can see here that there's party time here. So if you feel like like all the cases are not being, you can just say default, and then default will just have whatever it is in there that that it will resolve to, if you don't have like the case for that specific value you trying to check the different cases. So if I make this, for instance, something like this, there's no case for that here. So what is going to happen is default, let's just call this default value, and then if we run this, so basically what we're gonna see is that it's not going to do anything specific. It's just going to log the final one because there's no case for it. Let's open that. You can see default value, which is what is pasted in here. So that's actually that one for switch. And then the next one is for and for each. So for and for each is actually something interesting that I also like use, but this is actually for when you want to manipulate or try to do things with a collection. And what a collection is actually something that contains more than one item, right? And the types that we have currently for that is arrays. And how we declare that is in, so for instance, if you have an array of int, right? So I'll just call it array is equals to new int, and then that, and then what I want to do is I'll just make sure that it would have like the items you add in must be of the same type. So I can't come in here to add like string. It's not going to happen because this actual array only takes a specific type. And also with an array you can actually declare the size of the array. But this is how you declare an array, and this array can be of any type. It can also be string, but if it's a string, then that means that your actual collection type would have to change to a string. So that means all this has to be a string. You can see there that it has to be the same, the same type. You can't have different types in a string, in an array, an array of a particular type. So just bear that in mind. And then in terms of for, like I mentioned, so for is one of the things that you want to that you can use to iterate what is happening in here. And what you can do is you can actually say int I. So this is how you actually declare a for loop. If we call it a loop, because it's actually going to iterate the items inside of this array. So we can say it starts from a 0. That's the actual index number, sorry. So you terminate it by using semicolon, by the way, and then you can say I is less than the array dot length. So you're saying that this is the condition, is you're initializing an actual variable that you use to actually do the the checking of the actual items on the array. And then the next code is to put a condition for this loop to actually stop the loop when this is no longer true. So just bear that in mind. And the last part is to actually increment your actual index. So index actually starts from 0. We start our index from 0. So your array, if you want to count the items in here, you don't start from 1, you start from 0. That is how it's actually been built in C#. So you start 0, 1, 2, 3, and that's why I have 0 here. So it's going to start when this loop starts. I is going to be of a value 0 in here, and then after I finish that first loop, it's going to increment by that, which is 1. So this is actually saying plus 1 in a way. So it's like you saying I plus 1. So when it's 1, I plus 1 again, we say 1 plus 1, which is equals to 2. So like that. But let's run this actually. So array, and then this is how you get an item in an array. You use that same I, because that is actually going to be incrementing starting from a 0, and then from there you can actually say console dot write line, yeah, and then we'll just write line there. So what this is going to do for us is it's just going to keep on looping through until it actually prints out everything that is in that array. I'm just going to run that now so you can see what I mean. So that's basically when you use a for loop. You can see there 1, 2, 3, 4 like that. So I can also change that to something else like banana. How do you spell banana again? Banana, apple, let's zoom out a little bit, orange, and then pear, right? And if I run this, it's still gonna give me what I need. So basically your for loop is also like what you use to actually try to iterate like a collection. So an array is one of them, and also For loop is actually one of the suitable ones for arrays because you can actually use the index. You can use the index. You can easily, I know some guys actually even do things like -1. You can actually compute on this based on whatever logic you have going on here. So that is actually it for array. I've touched on array. I'm just going to change this now to another collection, which is list. That's another one that we'll make use of, and this is how you declare a list. Okay, I'll call this a list, and this is actually coming from an inbuilt namespace, which is system collections.generic. And how you instantiate that is actually a little bit different from what we have here. So we just say list of string. Okay, and then you can see that I have a list of string now, which is amazing. And then I just want to touch on the next one, which is for each. So for each is the next one you can use for control flow, but the way you do it for each is different. Yeah, you can actually just declare a variable item and you can say in list. So what you're saying is for each item in this list, right, which will be whatever you have there. You can see I have banana, apple. So if I say console.write, then item can be displayed. Okay. So that is actually just iterating the actual for each. It's just going to iterate that collection and actually print out the necessary items in there. So you're seeing items in that list, so it will go, and I can put a breakpoint here so you can see what is happening. If I put a breakpoint there and then run it, and then you will see that it's actually going to, you see it's stepped there. If you overthrow on the item, you can see banana is the first one picked up, is the first one in the collection. Go on, and then apple, then the next one is orange, then the next one is pear. So you can see that it's actually just basically that. And also one of the controls that you can also play with here is you can do things like continue. So I know that, let's say for instance now you want to stop doing the iteration if there is something that you've got. So let's say for instance now you can put if here and say item is equals to, if item is equals to apple. Let's say you want to stop this loop when it's actually equals to apple, you don't want to run it anymore for some reason, then you just put a break in there. Remember, like I said, if it's just one line of code, you can avoid the curly brackets, but you can also put the curly brackets if you want to, the curly bracket right there. Yeah, you can do whatever. But if we run this now, guess what? How many items do you think you're gonna see on the console, if you can guess? This is just going to print out one banana, and the reason why is because you can see here it's only going to print out banana, and the reason why it's going to print out only banana is because we're breaking the loop. We're saying, so break is one of the things you can use to break the loop, because you are saying if it's equals to apple, you don't want to run this line, just leave the loop. So at this point it's gonna just leave the loop, and I can show you now if I step through it so you can see what I mean. So you can see, so this is the first one, right? The item here is banana, right? That's banana. So it's not gonna break it. It's just gonna keep on going in the loop, and it's gonna fetch the next one. The next one is actually apple, right? But apple is gonna step into this block and it's gonna break out of this loop. You can see it's going out. So that's where the actual control actually ends. So those are the key things that we use in terms of programming. We use if, else, switch, for each. I still use it now. I've been using it for years and I'm still using it now, and it still works for me. So that's one of the key things you have to bear in mind. You can see there is banana, and also you have your the next one I want to just touch on is the cases where you have something like using, right? Using is one of the ones as well that is really important, which is disposal. and we can just call this new my first class. Is my first class still available? Okay, we've changed this. Let's just change this to my child class, right? And then take up, yeah, okay. So one of the ones I want to pay attention, I also want to like touch on is while loop. Okay, so while loop is one of this as well. And then the while loop is actually the one that actually just keeps running like through whatever logic you have in here based on the condition, if it's always true. So let's say I have a list here, dot count is greater than 0. Okay, so what I'm saying is while the list is greater than 0, just keep on going, looping through this the right line, and then we can just say list dot you can also we can just use there's a function within here that we can use, but let's just do this. Let's just say is 0. Let's just use 0. Okay, like that. And then what I'm gonna do is once it logs that, I'm just gonna remove the actual record there. So it will keep on removing the records from the list as the while loop goes on. And what that does is after the final end, when it gets to the final end, it's going to exit. Just be careful of this while loop, because you can end up just having this loop going on without stopping if the condition is not changed within the actual the scope of the while loop. So just bear in mind that is actually very crucial. But you can see here that it still prints out and it exits. So let me tell you what I mean by that. So let's say for instance I didn't put this. What is going to happen is this thing is just keep on going to be looping. It would not stop. So just be careful of that, because you can run into Stack Overflow exception, which means that it's gonna just keep on using the memory intensively, and then at some point it's just gonna crash if it doesn't have enough memories. You can see banana. So you just have to be careful of the while loop, because it can actually go if you don't control the condition within your the actual loop itself, then it might cause a lot of problems down the line. That's why so what I'm doing here is I'm removing it from the list as I'm logging it. So if I put a breakpoint here, so you can see when the list came in, it came in with all of this, which is banana, apple, orange, pear. And then what I'm doing is I'm actually just printing it out and then removing it from the list. So if you check here, I have 4 in the list, but if I go to the next line, you see that is now 3. So you can see, go to the next one. If I go over that line, you see it's 2 now. So that's how you can see until 1, and then the final one is 0, because now it's empty. The list is empty. So that means that when it tries to run the next condition, which is list, so list is no longer greater than a 0, so it's not going to run the while loop anymore. It's just going to step out of that control flow, and that is it basically. And that is why you have this, you can see there, because it's just logging it, writing it out, and then removing it from the list. So just bear in mind with that. So the final one I want to show you guys is the try catch. This is another exciting one, and this one is actually for cases where there's a possibility of an exception happening within your code. So you can see I have try. So anytime you see a curly bracket, this is actually a scope in a way. So anything I put in here will run for try, and anything I put in here will run for catch. But what this means is when you have a try, what you're saying is that the code you have here, so code I have here may crash or impact the application negatively. And what you're just trying to do is you're just trying to undo it. So, and that's what we call exception, in cases where your code is gonna cause some issues down the line. And an example is this. Let's say I declare a boolean, or sorry, let's say I declare, okay, that list, actually let's use this list as an example. List is equals to well, let's declare a variable. So a variable, and just say new list. Let's just say new list is equals to new list, or no, let's just say no. Okay, let's say no, which is it's nothing, right? And let's just make this this same list. Let's just make it this type of list, and let's just remove that. Let's just set this list. So we're setting this list to no, right? We want to like make it no. But now I want to do something like list. So sorry. So I want to do something like this: console dot write line, and then I want to say list dot count. For instance, I want to count the actual item on the list. Remember that I've actually set this list now to no. That means it has nothing in it anymore. It's like nothing, absolutely nothing. What is going to happen here is that it's not going to be able to run this, because this is actually no doesn't have any method on it at runtime. And I will show you what I mean by that. Let me put a breakpoint here. But it's going to step in here because now there's a problem. It doesn't know how to handle that problem. And that is one thing try catch actually helps with, because now you can actually say that so you can see no list is no, and the count is going to throw an exception. So if I say continue, it's going to step into the next so let's just continue, and then you can see it's going to step into this actual space. And this is because this is actually a problematic, you know, a problematic code. And yeah, this is where you handle it. Instead of it crashing the entire application, or you know, just stopping the application, you are not handling that exception, that problem. And this is where you just say, maybe yeah, you can actually have a mail so you can have a mail sender to report the issue. So this is where you can actually plug in a mail sender to say, okay, send this, or you can plug in a logger, okay, log the exception, so that the actual support guys or the dev guys can actually troubleshoot this at some point to say, okay, what is really happening there, and then they can go fix it to say, oh wow, but who set this to no, and then they can easily fix it. And on top of try catch, you actually have another block, which is finally. That's another one that you know, people used to forget about. Finally is actually like it's always gonna run. So this finally is, if any problem happens here, it's still gonna run. If this still works positively, it's still gonna run. So this is actually just where you can do some sort of like a cleanup or something if you want to. But this is actually one of the blocks you can use for. So this block will always run if you have it like declared in your try catch you know, flow. This part is where you run in your code, and this part is where you undo any problems within this space. And then this is where you do some cleanups, disposing of anything that you want to do. But this is actually just the actual control flow, and I think this is actually it. This is quite a lot. I hope you were able to learn. This is actually a crash course for beginners. I hope you have more information now as to, you know, how you can do things in C#. I would actually encourage you to look at the links in my description and actually just, you know, just do it. You know, do it from there. And then once you're getting much more comfortable, then you can actually start looking at my next video, because my next video as well is going to be looking at object-oriented programming. This is where we're going to look at things like, I've touched on it a little bit on here already, like your inheritance, your polymorphism, your encapsulation. I've touched on it, but I still want to like spend some time on it a little bit more, so that you guys can actually have more clarity. I'll do it with solid principle. I think I'll merge that two together. I'll do solid principle, and I'll show you all these different techniques you can use within, you know, your .NET application. And I hope you guys, you know, enjoy this. I hope this is gonna add value to you guys. And yeah, I'll see you in my next video. Keep